Hello students, welcome back to my channel. So today we are going to start the physics, the first chapter for 12th standard or PUC second year, that is electric charges and fields. Okay, so simultaneously I'll be covering the first year also and the second year too. So let us start with the first chapter, that is electric charge and fields. So wherever necessary you can take the screenshot and you can revise the chapter. So first of all, let us see the properties of electric charge. So from here only your basic charge chapter starts. So let us see what is a charge first. So charge is nothing but it is a entity which attracts another charge or repels another charge. Okay, so let us see the properties. Like charges repel each other, unlike charges attract each other. So this is a complementary property. So main properties are: charge can neither be created nor destroyed, it can be transferred from one body to another. So that means it is conserved. The charges are conserved. First point is charge is conserved. Then the second point is the charge is quantized. So that is charge on the body is always on the integral multiple of charge of an electron, Q equal to plus Ne, plus or minus Ne. So this is the formula you have to remember throughout your second year and your entrance exams. So this one is very important. That is charge is quantized and its value is Q equal to plus and minus Ne, where N is the integral multiples of the charge in a body and E is the magnitude of the charge. This is very important. So you have to remember the magnitude of the charge, that is 1.6 into 10 to the power of minus 19 Coulomb. Okay, always remember this magnitude of the charge. Okay, now so here you can see one point in the center. Charge of proton is taken as positive and that of the electron it is taken as negative. Charge of the proton is plus E, charge of the electron is minus E, but the magnitude, the value will be same. So proton is positively charged, so number of protons is equal to number of electrons that you know in an atom. So therefore only the sign changes. Okay, the polarity of the charge changes here. Proton will be positive and the electron will be negative. Then charge on a body can never be in fraction. So charge is a complete entity, it will not be in the fractions, that you remember. It will be asked in your MCQs. Okay, so full complete magnitude is, or the whole number is the value of a charge. Additivity of the charge. So if there are n number of charges, it will, the total number of the charges in an isolated system will be added. Okay, so whether it is plus minus also, then you can take the magnitude and subtract it. So that is Q equal to Q1 plus Q2, so on Qn. So n number of charges. So redistribution of the charge. Q dash equal to Q1 plus Q2 by 2. So if the two charges are coming closer to each other, they will exchange their magnitude by 2. Okay, by half. Then charge on the pendulum. So always you can see here, if this is a pendulum, if on this bob there is a charge Q and it is having, and it is moving in a electric field E, then tan theta is equal to QE by mg. So how we will take this? That is equating by the acceleration due to gravity and the tension, the force. Okay, the force here and here it is the weight. So tension on the string is equal to the force of the charge, so that is Q into E. So sin theta equal to R by 2L. So taking this triangle, so sin theta is R by 2. This is the length from the center, R by 2, and L is the length of the thread. So theta is very small, then tan theta equal sin theta equal to tan theta. So we will equate this to R by 12 equal to K Q square by R square by M into G. So, substituting the Coulomb's force. So here what we get, R cube is proportional to Q square. Then let us come to the Coulomb's law. Coulomb's law is what? It is the force between the two charges. Okay, so how it is, the force is how it is contributing to the two charges. So that is, if there are 2 point charges Q1 and Q2, now these two charges are positive, hence it has a repulsive force, right? Okay, so here you can see from Q1, force F1 is moving in the outer direction, and also F2 is moving in the other direction. They repel each other. But whereas in the second diagram, you can see very next here down below, you can see that Q1 is positive and Q2 is negative. Then the forces F1 and F2, they are attracting each other. Okay, the distance between them is R. Okay, now if this, again there is a dielectric medium here, K equal to, so Coulomb's law is, it is the force between the two charges. So that is, force is directly proportional to the magnitude of the product of the two charges and inversely proportional to the square of the distance between them. So F equal to, the proportionality constant is taken as K into Q1 Q2 by R square, where K value is 1 by 4 pi epsilon naught experimentally, because the charge is taken as the sphere, two spheres, and epsilon naught is the permittivity of the free space. Okay, so what it comes as the answer for K, 9 into 10 to the power of 9. Okay, Newton meter square by Coulomb square. This is the SI unit of K. Then epsilon naught value is 8.85 into 10 to the power of minus 12 C square by N meter square. Okay, so this is the, if the two charges are placed in a dielectric medium, so K value, it depends as F medium equal to F air, that is the force in air when the charges are kept in air, divided by the dielectric constant. So that dielectric constant will be given, it will be given, or if it is not given, other terms can be given. You can find out what is the answer. So for water, K is 81, in vacuum K is 1, and for metals K is infinity. Okay, so thank you for watching my channel. Please do like, share, subscribe and comment in my channel. Thank you.